All right, so good morning, good evening, good afternoon, and what's up, people? What's up, my students? Absolute value functions. What we have is lesson 3.8, the final lesson in chapter 3. So let's get started on this. No bell work yet. We'll start in chapter 4. So we worked on doing some piecewise and step functions the previous lesson. Now we're going to concentrate on absolute value functions. Here's the key term for you guys to remember this time. Vertex. Big functionality. We will start talking about vertex now, and then when we get into quadratics later, it'll become a very important term. Here's an absolute value parent function. Left to right, the domain is all real numbers. Okay? The range is all non-negative real numbers. If you do not have your book open, please, ladies and gentlemen, pause this video and turn your book to page 205. It is very important because I actually am not giving, I'm not giving out, so happens when you drink Diet Mountain Dew. I am not giving out notes for this function. Instead, ladies and gentlemen, what I'm giving out is just graphing paper so that you guys understand we're just moving things around on this lesson, okay? We are not, you're going to write the equation down, you're going to graph it yourself, but we're going to function a lot with Desmos, okay? So this one's going to be another Desmos heavy graph. On the top of page 205, you will see an example that I want to make sure you guys are fully aware of. And it is this one right here. It talks about y equals a absolute value function of x minus h plus k. Okay? When you graph that in Desmos, it just comes up as your parent function h of k because I have a 0 value for k, h, and then my a, which is my front value, is just 1. So this is basically saying y equals the f of x, or the y equals absolute value of x. It comes down, it bounces off the ground just like a bouncy ball. If I threw it at the ground, it would hit the ground and go back up at the same rate. Okay, so what we're working on is what is the h function, what is the k, what do they respectively do, and even the a value, which is in the front. They're all constant. But what happens when you manipulate those and you change them? So that's what we're kind of getting into. So on this one, graph g of x and the absolute value of x plus 4. So in this function, the k is this back end. Okay, so at the outside of the equation, if you guys go to Desmos right here, the k function sits on the outside. So what happens when your equation is plus 4? All right, what does it do? That's what I want to make sure you guys understand. When it's plus 4, so my k, I'm going to take and move to 4, and as I'm moving it, look at the graph. It went from the 0, 0 origin, and I just did what? Moved it up. So the k value, what does the k value do? It actually takes, ladies and gentlemen, state the domain and range, and describe how the graph is related to the function of f of x. So the domain, d equals the all real numbers, okay, so it's negative infinity to x to infinity. My range starts at what? It's going to equal 4, because if you guys look back at your graph here, it starts at 4 and it's equal to it. 4, and it's going to be equal to y, and then it is infinity. So every number stops at 4, every number greater than 4, but it's going to not equal to, but stop at infinity. It's going to go infinity beyond. And then, ladies and gentlemen, describe how the graph is related. It moves up 4 units, okay? If you do not have the notes pre-printed for this, you're going to have to write this on the graph paper. So I know it'll be kind of weird probably to do it, but just help you guys understand that this is kind of what we're looking for in this functionality, okay? You try it on your own. All right, if I were to graph this one, ladies and gentlemen, what do you think it's going to do? Minus is going to actually take it from the original vertex and it's going to drop it down 1. Now, I can continue to draw this out. I'm choosing not to. But it's going to drop it down 1 point. So my domain is still going to be all real numbers. Okay, so it's negative infinity, x to infinity. My range, though, is going to be what? It's going to stop at the negative 1 value. And then it's going to be equal to y, which is equal to infinity. And then what is it related to? If it's a negative, it's going to move down 1 unit. -1 unit. Okay, that is it. Hopefully you guys understand that. That's what I'm looking for in the homework. If I give you more examples like this, you'll need to tell me the reflection of it. Starting from 0, what happens? Where does the graph move and how does it function amongst everything? All right, so that was the K value, which is on the outside. Now we're going to focus on the H value. So in this case, the H is a what number? -3. All right, that is the K value on this one. So we're going to take this K, the H value. We're going to take the K and go back to 0. So we're starting at the origin. And then X is going to be negative, or H is going to be negative. So if it's negative, see how it's moving? -3. So when I moved it, my negative value, all I did was move it what? Negative moves it to the left, kind of how you would figure. So what is describe the relation, state the domain and range? Well, the domain is going to be all real numbers, okay? This doesn't change. And my range, ladies and gentlemen, it did not move up and down, it just moved left and right. So it is 0, y to infinity. Hopefully you guys see that. Now, describe what it happens to the relation to the graph? Well, the graph moved how many units? 3 units to the what? To the left. To the left. Okay? Hopefully you guys saw that. As we moved it, negative value, it's going to move it, of course, to the left. Now, that's within the parentheses bracket. Ladies and gentlemen, you try. All right, of course, when I move it +2, what do you think it's going to do? If I go, so it's going to be H. If I look at my graph here, I'm actually going to, this is negative, so my H is now going to be a +2. When it is +2, ladies and gentlemen, it moves to the what? To the right 2, okay? My H is going to be AX +2. If it's a positive number, it moves to the right 2 values. So, does my domain and range change? My domain, sorry, that was weird. Domain equals still the negative numbers, okay? And then the range starts at 0, and it's equal to it. Can never equal infinity. So that's why we write this part right here. And then my graph, the graph moved 2 units to the right. So hopefully you guys can kind of see and correlate. It moved 2 units to the right. Okay, now that we've covered the K, we've covered the H, now we're going to cover the A, which is on the outside of the equation. So if I go back into here, it says what is -1/3? Take a while, guess what's going to happen on this? So let me move my H back to 0. So now we're at 0, 0, 0 all the way across. Stay. Stupid thing. Stay. There we go. 0. Now we're going to take our A value. And I'm going to move it. Now, I don't have the ability to do a fraction. If you guys were to put 1/3 in a calculator, you would get 0.3. So the equivalent, I put that in quotation marks, negative would be 0.3. So if my negative value is 0.3, look what happens. It actually switches it, okay? If it's negative, it's going to flip the vertex, or flip how it's open. As you guys saw, it's going to be open down because I'm going for every negative value on the outside. So if the absolute value inside is always going to be a positive number, if I attach a negative to the outside, what is happening? It's actually flipping this equation. So as it reaches here, it's still going to be negative value. So the negative H or Y value is always going to be down. So how is this related? Well, my domain is still going to be what? Negative infinity, X, oh, forgot my mark, to infinity. But my range now, where did my range stop? Okay, my range is going to be, if I look at this, it's actually going to be every value less than 0. So, on this, ladies and gentlemen, how would you write that? Uh-oh, I think I lost that. What you would do is it would be 0, less than, or equal to y less than to negative infinity. Okay? So every y value that is still going to be greater than negative infinity, but it's going to have to be stuck at 0. 0 is the greatest number. That's how you would write this. Now what happens to the graph as related to the f of x function? Well, what I want you guys to understand is there is a concept, but since that thing shrunk, let me go pull it back up. Actually switch back to my other screen. If you guys look at the bottom, okay, of this little particular, it says when A increases, there was what's called a vertical stretch. And when A decreases, there's what's called a vertical shrink. So, in essence, ladies and gentlemen, when A decreases, it's called a vertical shrink. So does this value shrink vertically? Yes, it does. So if you imagine opening like a flower, okay, if it's a stretch, it's going to stretch it straight up. So if I put a 4 in front of this or a 3, the values of this is going to shoot straight up to absolute value. But the lower the number is, the wider it's going to open. So it's called vertical stretch and vertical shrink. We'll learn about this later, but please write this down right now. Okay, hopefully you guys wrote that down. And so let's begin. The next one is, what is 1/2? If I did 1/2 on here, if I just change this, 1/2 would be a positive 0.5. So positive 0.5, you guys can see it shrinks down a little bit. And so what actually happens is the rise now becomes what? 1 up over 2. So it is 1/2. So you're just multiplying it, and you're actually taking your vertical and you're shrinking the vertical. So what I mean, if you guys look, see how if I make it a larger number, it's actually making it so that it's stretching it out vertically speaking. It's going to go farther up. And then vertical shrink is when I go less than 1, it actually will shrink it very rapidly. Okay? Kind of like a butterfly flapping its wings, imagine that. But that's the value. So what happens with that? Your domain and range on this one, your domain is all real numbers. Your range is every number greater than 0, kind of like what we've been doing. But in this case, it shrinks it out to 1/2. All right, next example here. What happens if you put the absolute value sign within? So it's negative 1/3 x. Well, what do you think is going to happen? No matter what happens, now this one's more difficult. I wanted to show you separately. If I put it in Desmos, negative 1/3 x, and I mark it, what happens? Well, ladies and gentlemen, it's negative, but inside the absolute value, remember anything that is negative is actually what? Positive. So the domain and range, domain's all real numbers, range, any number greater than 0. So please make sure you continue to write that functionality. Okay, here's the range. The domain, we've written it multiple times. Here's the range. Please make sure you guys write that down. And how does it relate to the graph of f of x? Well, it actually vertically stretches it out, okay, to 1/3. It makes it more difficult. It's not as 1-to-1. What happens if you do half? The half of x is kind of what we just did, okay? It's going to actually take this value and it's going to make it so that it's still the same thing, but it's 1/2. Doesn't really change anything. So if the multiplication is on the outside or on the inside, it doesn't really make too much of a difference at this. Last but certainly not least, I want to make sure you guys understand, here's a word problem. Here's the function. Models a swimmer's distance in meters from the far end of the pool after 0 seconds. Graph this function. How many meters is the swimmer from the far end of the pool when the timer begins? So you would actually set this up. When I graph it, okay, I turn it on, and do I see it? No, I don't. So I actually have to zoom it out, and here it is right here. So what this is kind of a reality-based situation. When the answer to this question is, where does it begin when the timer is at 0? When the timer's at 0, he's how far? It's 50 meters. And it takes him 25 seconds to swim to the other side of the pool. He touches the wall, and he swims back to the other 50 meters. So technically, I would want to end this graph right here. So that's how you swim. You swim from one end of the pool, it takes them 25 seconds, go back to the other end, it's 50 meters. They're swimming really, really, really slow. If you guys have any questions on that, please let me know. But that's the functionality. So what is it? Where does it begin? It begins at 50 meters. Okay, if you guys want to graph that out, you can. The graph I provided in the notes was too small, so that's kind of why I went to a different one. Now, here's another thing. The function 3 on the outside, x minus 8 minus 24, models a dolphin's elevation in feet to compare it to sea level after x seconds. Graph the function. How far below sea level is the dolphin at the deepest point in its dive? So, we just want to graph this function out. Now, I cheated the system on this one, and instead of me changing everything at the top, I just did it straight up. So what you're doing is that you want to find out, it says, here's the function, where's the deepest point? When you graph it, well, your deepest point is going to be down here. And on Desmos, that's the cool thing about it, is this will actually give you the vertex. So this, ladies and gentlemen, is your vertex. It's the farthest point, either north or south. So this is the farthest point south before it turns and goes the other way. What is my farthest depth? Okay, my farthest depth on this is going to be negative 24. So the answer to this equation, how far below sea level is the dolphin at its deepest point in its dive? The answer is going to be what? Negative 24. Once this dolphin hits negative 24, what's it doing? It's coming back up for air. So ladies and gentlemen, I hope you guys understood this lesson. In your homework, that'll be in the comments, what I want from you is to tell me how many units it functions. Like for example, if I were to ask on this one, what is it related to parent function of the f of x? Okay, I would want you to tell me that it moved over to the right. It moved 8 units to the right and 24 units down. Okay, 8 units to the right, 24 units down. Any question on that? So that's what I want from you guys. Okay, please understand what the h does. Okay, what the k does. Remember, the k moves it vertically. The h moves it left to right. And then the a value on the outside will shrink it, will stretch it out vertically, or will shrink it vertically. Okay? Understand how we're doing this because this will be important as we move forward. Ladies and gentlemen, if you have any questions, please come see me in class. Otherwise, work on the homework, and then I will talk to you guys later, and I hope you enjoyed Chapter 3.